Yes, today I am going to explain linear differential equation. Okay, right. Linear differential equation. Okay. So any differential equation is of the form dy by dx plus py is equal to q. Any differential equation is of the form dy by dx plus py is equal to q, where p comma q are functions of x, are continuous of or continuous functions of x. Okay. Yes, if p comma q are continuous functions of x, then dy by dx plus py is equal to q is called a linear differential equation in y. Okay, right? Is a linear differential equation in y. Okay, so how to solve this type of linear differential equation? So here, alright, e to the power of integral s p dx. Okay, first I have to concentrate intermediate and board. Okay, right? Next video I will tell you for degree purpose, right? So this one is only intermediate purpose or CBSE model. So any p comma q are functions of x, are continuous functions of x, then dy by dx plus py is equal to q is called a linear differential equation in y, right? So e to the power of integration p dx is called an integrating factor. Integrating or kind of factor. Simply denoted by like this IF, integrating factor. Now general solution is yes y into okay, IF is equal to integration q into yes IF into dx plus c. This one is general solution of a linear differential equation in y. Y into integrated factor is equal to integration q into integrated factor into dx plus c. Okay guys, if p comma q are continuous functions of x, then dy by dx plus py is equal to q is called a linear differential equation in y. Okay. So e to the power of integration p dx is called an integrated factor. Okay. So general solution is y into if is equal to integral q into if into dx plus c. Okay. One question given that dy by dx plus 2y by x is equal to 2x square. Now given differential equation is dy by dx plus 2 by x into y is equal to 2x square. Now it is of the form dy by dx plus py is equal to q, where p is equal to 2 by x and q is equal to 2x square. Now first to find integrated factor. Integrated factor is equal to e to the power of integration p dx. Okay. So this is equal to e to the power of integration p is equal to how much? 2 by x into dx. So e to the power of 2 is constant. 2 into integration 1 by x into dx. So this is equal to e to the power of 2 into x. Integration 1 by x into dx is equal to log x. Right. Log x. Since integration 1 by x into dx is equal to yes log x. Okay, of course plus c. Now the here e to the power of this one is equal to log x square. Since right, m log x is equal to x to the power of, okay, right? So this one is right log x to the power of m. So 2 log x is equal to log x square. So this value is equal to x square. Since e power yes log x to the base e is equal to x. Okay, now just I told now general solution is yes y into if is equal to integration q into yes if into dx plus c. Okay, now y into if is equal to how much? X square. X square is equal to integration q is equal to how much? 2x square. 2x square into if is equal to how much? X square into dx. Okay, plus. So this one is x square into y is equal to 2 constant integration x power 4 into dx plus c. Right. Now this implies x square y is equal to 2 into x to the power of 4 plus 1 by 4 plus 1 plus c. Since integration x power n into dx is equal to x to the power of n plus 1 by n plus 1 plus c. So that's why x square y is equal to yes 2 by 5 into x power 5 plus c. Yeah, this is the answer. Okay, right. So once you convert whatever the equation, that equation into, is it possible to convert that equation into linear differential equation and y or not? That is very important. So it is a direct question with this one, dy by dx plus, okay, right, 2 by x into y is equal to qx square. No doubt, it is of the form dy by dx plus py is equal to q, where p is equal to 2 by x, q is equal to 2x square. Now integrating factor e to the power of integration p dx. Here p is equal to 2 by x. 2 is independent of this integration. 2 into integration 1 by x into dx. Now, so we have the formula integration 1 by x into dx is equal to log x. Now m log x is equal to log x square. Okay, e power log x to the base is equal to how much? X. That's why according to this formula, this value is for x square. Now the general solution is y into if is equal to integration q into if into dx plus c. Now y into x square is equal to like this. Okay, so integration x power n into dx is equal to x to the power of n plus 1 by n plus 1, just like this. Okay guys? Yeah guys. Now next one is linear differential equation is of the form dx by dy plus p into x is equal to q. Okay, right? Here p comma q are functions of y. P comma q are functions of y. Then dx by dy plus px is equal to q is called a linear differential equation. Is called a linear differential equation in x. Now how to solve this type of equation? So first to find okay, integrated factor. Integrated factor is equal to e to the power of integration p dy. Okay, yes. Now second part is general solution. General solution is x into if is equal to integration q into if into dy plus c. That's it. Okay. So any differential equation is of the form dx by dy plus dx is equal to q. Then this type of equation is called a linear differential equation dx. Right. So first to find integrated factor. Integrated factor is equal to e to the power of integration p dy. Why? Because p is a function of y. And general solution, GS means general solution is x into if is equal to integration q into if into dy plus c. So derivation part is not important. So simply remember this. The general solution of the given equation is x into if is equal to integration q into if into dy plus c. Right? Yeah guys. One example. Look at the board. Yes. dx by dy plus px is equal to q. Okay, right, linear differential equation x. Now one example given. Okay, right. So here x plus y plus 1 into dy by dx is equal to 1. Is it possible to convert this equation into a linear differential equation in y? No. Okay, right. So why? Because look at this. X plus y plus 1 is equal to dx by dy. Shifting this side. Okay, right. So this implies yeah dx by dy, yes, okay, minus x is equal to y plus 1. Now this implies dx by dy, okay, plus minus 1 into x is equal to y plus 1. Now it is of the form dx by dy plus p into x is equal to q. Okay, where p is equal to minus 1 and q is equal to y plus 1. Now first to find integrative factor. So integrative factor is equal to e to the power of integration p dy. Okay guys. So this is equal to e to the power of integration p is equal to yes minus 1 into dy. So this is equal to e to the power of minus of integration dy. So this is equal to e to the power of minus y. Integration dy is equal to y. So general solution is yes x into if okay is equal to integration q into if into dy plus c. So x into if is equal to e to the power of minus 1 is equal to integration q is equal to how much? Okay, y plus 1. Y plus 1 into e power minus y into dy plus c. Okay, now so this one is x plus y plus 1 into dy by dx is equal to 1. So it is not possible to write this equation into a linear differential equation in y. That's why second alternative method is conversion into a linear differential equation in x. So that's why x plus y plus 1 is equal to dx by dy. Now dx by dy is equal to shifting this side minus x is equal to y plus 1. Right now, so dx by dy, this can be written as plus 1 into plus minus 1 into x is equal to y plus 1. Now compare this equation with a linear differential equation x dx by dy plus px is equal to q, where p is equal to like this, p is equal to minus 1 and q is equal to y plus 1. Right? So integrating factor e to the power of integration p dy is equal to e to the power of integration minus 1 into dy, e to the power of minus integration dy is equal to e to the power minus 5. Now general solution is x into if is equal to this one is general solution. Right? X into if is equal to integration q into if into dy plus c. Now x into if is equal to how much? E power minus 5. So integral q is equal to y plus 1 into if is equal to e power minus 1 into dy plus c. Now x into e power minus y is equal to integration yes y into e power minus y, okay, right? Plus e power minus y into dy, okay, plus is equal plus c, right? So this is equal to actually no need to this splitting this one directly, but with respect to student point of view it is very easy. Integration y into e power minus y plus e power multiplication y into e power minus y plus 1 into e power minus 1. Now this is equal to integration yes according to the Euler formula. Euler formula, I inverse is not there, logarithm is not there, algebra is there. Yes, this one is algebra and exponential function is 2. Okay, right. So integration y into e power minus y into dy plus integration e power minus y into dy plus c. Okay, right. Now applying the integration by parts is equal to integration yes integration f of x into g of x into dx is equal to f of x into integration g of x into dx minus of integration f dash of x into integration g of x into dx okay plus this is okay right integration okay by parts. Yeah. So x into e power minus y is equal to, f of x is equal to y into integration e power minus y into dy, okay, minus integration dy dy of e power minus y f dash of x. So with respect to y by this one into integration e power minus y into derivative of, sorry, yes, d by dy of y into integration e power minus y into dy plus c. So this is equal to y into integration e power ax. Integration e power ax into dx is equal to e power ax by a plus c. This is the formula. So x into e power minus y is equal to y into this value is equal to e power minus y by s minus 1. Of course, this value is equal to, look at this, minus 1 into y. Okay, here e is equal to how much? Minus 1. Minus of integration derivative of y with respect to y is equal to 1 into e power minus y by minus 1 into dy plus. Now this one is x into e power minus y is equal to minus y into e power minus y, minus into minus plus. Now integration e power minus y is equal to e power minus y by minus 1 plus c. This one is x into e power minus y is equal to minus y into e power minus y, okay, minus e power minus y plus c into e power 0. There is no change the value. E power 0 is equal to 1. So this implies x into e power minus y is equal to minus y into e power minus y minus e power minus y plus c into e power y into e power minus y. Bases are equal, power should be added, e power 0. Right? Is it necessary, sir, to write like this? No need that one. Enough? This one. Okay, right? So this implies x into e power minus y is equal to e power minus y common. So this implies minus y minus 1 plus c into e power y. So this one cancel. What will get? X is equal to minus y minus 1 plus c into e power y. So x plus y plus 1 is equal to c into e power y. This is the final answer. Actually, look at this. This one is no need to apply integration or by parts. We have one method is there like this. Integration, for example, x cube into e power ax into dx. Integration x cube into e power ax into simple method I will tell you. Listen better. First one is x cube. What the derivative of x cube? 3x square. What the derivative of 3x square? 6x. What the derivative of 6x? 6. Okay. X cube. Next derivative of x cube 3x square. Derivative of 3x square 6x. Derivative of 6x is equal to 6. Okay. Now integration of e power x like this. E power x by a. E power ax by a square. E power ax by a cube. E power ax by a to the power of 4. Okay. First one is plus, minus, plus, minus. Let's see. This is a simple method, this one. Integration x cube into e power x into dx is equal to reduction formula written directly. Integration x cube. Similarly, x power 4. X power 4. Derivative of x power 4. Okay, 4x cube. Derivative of 4x cube. 12x square. Derivative of 12x square. 24x, derivative of 24x, 24. Yes, e power x by a, e power x by x a square, e power x by a cube, e power x by a power 4. Just like this. Simple method this one. Okay. No need to write every time like this one here. So here simple. Okay. Calculation is minimized by using this type of notations. Right? What is differential equation? Okay. So linear differential in y completed, linear differential equation x completed. Now final condition is Bernoulli's differential equation. So here A differential equation is of the form dy by dx plus py is equal to q into y power n. Any differential equation is of the form dy by dx plus py is equal to q into s y power n, where we come up to our functions of x. So now divide the above equation with yes y power n. Now this implies 1 by y power n into dy by dx plus p into yes y by y power n is equal to q. Now this one is y power minus n into dy by dx plus p into y power 1 into y power minus n is equal to q. So this implies y power minus n into dy by dx plus p into bases are equal, power should be added, 1 minus n is equal to q. Now convert this equation into the standard equation of the linear differential equation in y or x. But here I consider that let y power 1 minus n is equal to z. I consider that y power 1 minus n is equal to z. Now differentiate with respect to x. So this implies 1 minus n into y power 1 minus n minus 1 into dy by dx is equal to dz by dx. Just you have to operate two differentiations. One is externally, another one is internally. So first we have to concentrate on 1 minus n. Derivative of something whole power n is equal to n into something whole to the power of n minus 1, whatever the value of something, right? So that's why 1 minus n into y to the power of 1 minus n minus 1 and the derivative of y with respect to x, that is dy by dx. We have to operate two differentiations. One is externally, another one is internally. Internal means base. So into dz by dx. So this implies minus 1 plus 1 cancel. Y power minus n into dy by dx is equal to 1 by 1 minus n into dz by dx. Here n is not equal to 1. Then substitute this equation like this. Okay, star. Now star implies this value is equal to how much? 1 by 1 minus n into dz by dx. Plus p into z is equal to q. Okay, now multiply 1 minus n both sides, dz by dx plus 1 minus n into p into z is equal to 1 minus n into q. No doubt it is a linear differential equation in z. Then applying previous model. Actually, don't concentrate this type of proof of the Bernoulli differential equation. Once you recognize initially, is it a Bernoulli or linear differential equation in y or x? Yes. How to recognize Bernoulli differential equation? dy by dx plus py is equal to q into y power n. Okay. Then what the process? Divide the whole equation with y power n, and that p into some value is there, no? This value is equal to say z or u or v, whatever like that. And convert that Bernoulli equation into linear differential equation. Then everybody knows how to solve that type of linear differential equation in z or y or x. Okay, this is the process. Okay, guys. Yeah, look at the board. Yes, dy by dx plus y by x is equal to y squared by x squared. Once you check it, is it a Bernoulli differential equation or not? Yes, no doubt. Why? Because dy by dx plus 1 by x into y is equal to 1 by x square into y square. dy by dx plus py is equal to q into y power n mod. So it is of the form like this: dy by dx plus py is equal to q into y power n mod. What the process? Divide the whole equation with y square. So divide the above equation with y square. Now 1 by yes y square into dy by dx plus 1 by x into y by y square is equal to 1 by x square. Now this one cancel. So this one is y power minus 2 into dy by dx okay plus okay 1 by x into y power minus 1 is equal to 1 by x square. Now this part is equal to z. Let y power minus 1 is equal to z. Okay, right. Now differentiate with respect to x. So this implies minus 1 into y power minus 1 into dy by dx is equal to dz by dx. Now this implies y power minus 2 into dy by dx is equal to minus dz by dx. So this is equation number star. Equation number star. Now star implies this value is equal to how much? Minus dz by dx plus 1 by x into z is equal to 1 by x square. Okay guys. Now multiply minus on both sides. So this implies dz by dx okay plus minus 1 by x into z is equal to minus 1 by x square. It is a linear differential equation in z. It is a linear differential equation okay, in z. That is dz by dx plus dz is equal to q. Where p is equal to how much? Minus 1 by x. Minus 1 by x and q is equal to minus 1 by x square. Now integrative factor is equal to the power of integration yes p dx. So this is equal to e to the power of integration p is equal to how much? Minus 1 by x into dx. Now here this one is equal to e to the power minus of integration 1 by x into dx. So this is equal to e power minus log x. Now this is equal to e power yes log x power minus 1. Why? Because m log x is equal to okay right log x power m. So this is equal to how much? X power minus 1 is equal to 1 by x. 1 by x. Since okay right e power log x to the base is equal to x. Okay right. Now what is the general solution? General solution is equal to z into if. Why you are writing z? Okay, it is a linear differential equation in z. So z into if is equal to integration q into okay if right into dx plus now z is equal to how much? Z is equal to where is that? Yeah, z is equal to y power minus 1. So y power minus 1 into if is equal to how much? 1 by x is equal to integration q is equal to how much? Minus 1 by x square into if is equal to how much? 1 by x into dx plus okay right yes 1 by yes y power minus 1 is equal to 1 by okay right xy is equal to yes minus of integration 1 by yes x cube into dx plus so this is equal to 1 by yes xy is equal to minus of integration x power minus 3 into dx plus now we have the formula integration x power m into dx is equal to x to the power of n plus 1 by n plus 1 plus c. Okay guys. Now so 1 by okay xy is equal to minus x to the power of minus 3 plus 1 by minus 3 plus 1 okay plus. Now this one is 1 by yes xy is equal to okay yes 1 minus 3 minus 2 minus 1 is cancel so 1 by yes 2x square. Why? Because x power minus 2 okay plus c. So here x power minus 3 plus 1 by minus 3 plus 1 means x power minus 2 by minus 2. This is equal to 1 by yes 2x square. That's it. This is the final answer. Okay. Thank you guys. Yeah, next video I will discuss okay, right, some gunshot questions here, right, for board point of view, right. Thank you guys. Love you.